Hello, welcome to video 3b. In this video, we're going to graph functions, linear functions, on restricted domains. Normally, lines kind of go on forever in both directions, but we're going to graph just the part that corresponds to a given range of x values. We'll see what all this means as we go through a few examples. All right, so here's our first one. In this example, we're supposed to graph the function f of x equals x minus 2. It's a linear function with domain -2 to 5. All right, that means for only those x values. Actually, it doesn't include -2 and 5. It's every value of x between those. All right, so one simple way to do this is to just make a table with values of x that are in between -2 and 5. Okay, so we're going to complete the table and then just plot them. All right, so let's put -2 into the function for x right here. So if we do so, we get -2, that's x, minus 2, which is -4. We put -1 in for x. -1 minus 2 is -3. If we put 0 in for x, 0 minus 2 is -2, and we kind of see a pattern here. Remember, linear functions change at a constant rate. As long as x is going up by 1, they're going to change at a constant rate too. And in this case, they're going up by 1 also. -4 to -3, that increased by 1. -3 to -2, that went up by 1. So the next one is going to be -1, 0, 1, 2, and 3. So now we're going to plot them. Now, I got to be careful. At -2, our very first point, there's a parentheses there, which means it actually doesn't include that point. So I'm going to put a hollow dot there. At -2, -4, which is down here, put a hollow dot. At -1, -3, that's our next point. Put a solid dot. That's in the middle of the line segment we're drawing. At 0, -2, a dot. 1, -1. You can kind of see a pattern here. At 2, 0 is there. 3, 1 is here. 4, 2 is here. And at 5, 3, well, that's at the other endpoint. It doesn't actually include that point. We're going to put a hollow dot. So we can kind of start seeing what we have. We have a part of the line segment that's in between these two dots. So what I'm going to do is I'm going to use the line tool here to actually kind of insert that line right there. Okay. And like I said, normally a line goes on forever in both directions, but we have the part of the line that has x values -2 to 5. That's the only part of the line we have. That's what it means restricted domain. Instead of the whole real line, only the part of the graph that's in between -2 and 5. Okay, now in hindsight, there's a little bit easier way to do that. I could have just graphed the endpoints and connected them. Right, so in the next example, we'll make this a little bit shorter. Okay, before we go, it asks, what's the range? That means, what are the y values that belong to the graph? So think, the lowest possible y value is this -4 right here. It actually doesn't include that. So I'm going to put -4 with the parentheses. And we have y values that go all the way up to 3. All right, so I'm going to put 3. And since that's a hollow dot there, parentheses. Not sure how much about range you've seen yet. We'll just bring it up now. But if you haven't seen too much of that, I'm sure you're going to see a lot of it in the near future. So don't sweat that too much. All right, let's move on to the next example. We're ready. So here we go. Our goal is to graph this linear function right here with this domain. So I'm going to graph just the endpoints. So I only put 2 and 8, the endpoints, because if I can graph those, I can just connect them with a line and be done with it. So we're going to put 2 into the function. We get -1/2 times 2 plus 6. On the calculator, you can just do this as -1 divided by 2 times 2 plus 6, which is just -1 plus 6, or 5. We're going to put 8 into the function, so we get -1/2 times 8 plus 6. Again, you can use the ABC key, or you can just do -1 divided by 2 times 8. That gives you -4 plus 2 is 2. Or sorry, plus 6 is 2. So I have the two endpoints. I see that the domain has square brackets, which means we want to graph this on the values of x that range from 2 to 8, including 2 and 8. All right, so we're going to use solid dots. At 2, 5, let's put a solid dot for that point. And at 8, 2, let's put a solid dot there. And we want our graph to extend for values of x in between those. So I'm going to get my shape tool and just draw a part of the line between those. Okay, that's the part of the line that lies in the domain positive 2 to positive 8. It's the part of the line that has those x values. All right, for the range, those are the y values that belong to the graph. Well, the lowest point of the graph is right here at 2. And the highest point is right here at 5. And we have y values that lie in between those two. And since these are solid dots, we're going to use square brackets. So the range is the set of outputs we can get from this function. It looks like we get outputs ranging from 2 to 5. All right. On this example, let's do the same thing. Let's just calculate the endpoints, or the function at the endpoints, and just draw that part. So we're going to put -3 into the function. We get -1/3 times -3 plus 4. -1/3 times -3, if you do on your calculator, is +1 plus 4 is 5. Let's put in 6. -1/3 times 6 plus 4. That's -2 plus 4 is 2. So, all right, let's plot those two. So -3, 5 is right here. 6, 2 is right here. And we want the part of the line that's in between them. Now, this Miller made a mistake here. I have to back up a little bit. This first endpoint is a parentheses. So actually, I want a hollow dot there. So at -3, 5, hollow dot. All right, now we're ready to connect them. It has a parentheses here, which is hollow dot, and a bracket here, which is a square bracket or a solid dot. So now we'll go ahead and connect it with the line tool. And there's the graph of our function. So for the range, I want to ask, okay, what's the smallest y value? How low does it go? It goes to 2. And how high does it go? It goes up to 5. The 2 has is included, so square bracket, and the 5 is hollow, so a curved parentheses. Right, a lot of details, but I hope you're getting the hang of it. I think it helps us to realize, got to graph the function at the endpoints, determine if they're solid or hollow, and then just connect them. One last type of example. This is another linear function, but we want to graph it on the domain x greater than or equal to 1. All right, so I only have one endpoint. So at x equals 1, we can put that in and find the value of the function. -2 times 1 plus 4, well, that's -2 plus 4 is 2. So we're at 1, 2, and it's solid because x greater than or equal to 1. And we want the graph for values of x that are to the right of that. So I can pick any value of x that's to the right, like 3. Okay, if I put 3 in, I get -2 times 3 plus 4. That's -6 plus 4 is -2. So I get 3, -2. I just need another point so I know how to draw the line. So x equals 1, that's one boundary point, and then it's the part of the line that goes past that. Well, all right, so we need one more point to kind of figure out the direction here. And I'm going to use my line tool and start there and go in this direction, and actually it keeps going on forever in that direction. All right, well, smallest y value. Well, it goes down forever to negative infinity. So lowest value, well, approaches negative infinity. The highest y value is right here at 2. That's going to be a bracket. Okay, that was a lot. But with a little bit of practice, you can do this with no problem. So here's your journal assignment. Sketch a graph of the linear function f of x equals 6 minus x on the domain 1 to 5. All right, good luck.